right, sweet. We're all set and ready to record. So hooray. Any event, welcome back. So the, sales pitch for this particular section is pretty straightforward. We're going to go ahead and play around with these regular expressions a little bit more. So to start this off, I got a super sweet little picture of a dude in a top hat saying, yay, RegEx, with an exclamation point. And off on the right then is going to be the corresponding regular expression that would then play with that particular phrase. So here you can see that there's a capitalized word with a space, and then REG with a capital R, and an EX with a capital E. And those things are actually stuffed next to each other with an exclamation point at the very end. So playing around with a few of these things, building up the machines, building up the corresponding regular expressions, and then we're going to go ahead and test some of these things against some known things that it should work with, as well as some known things that it should break on. So to begin, I actually want to double back to one of these languages that we've already built a non-deterministic machine for. So that is this world of all possible decimal numbers. So down below, I have 3 of them just to kind of remind us what a decimal number looks like. I have the negative 13.37. We have Jenny's phone number, so 867.5309, and then negative 0.42. So all of these are honest to goodness little decimal numbers. 2 of them happen to be negative, which we allowed for, and they all do in fact have this nice little decimal point separating some possible collection of numbers. Obviously the 0.42 doesn't have a number in front of it, and I'm saying that's totally okay. If you remember, this was one that we actually first built up this little non-deterministic machine with this little epsilon transition. We have this possible negative sign on the very beginning, and that was achieved with this little epsilon. Basically, I could start this game up at S0, or I could start this thing up at S1. If I started at S1, then I'm essentially not having the negative, and then I can do whatever I want to. And if I started at S0, then I pick up the negative and then again, do whatever I want to afterwards. What's really nice about this particular language is that once we have this machine built, it's actually really easy to take this machine and convert it into a regular expression. And then we can actually go through and test it and do all of the things that we know and love. So let's go ahead and actually run this. So the first thing that you can see is that I have this possible negative sign right off the bat. And if you remember from the last section, this is easily achieved with this little question mark, which is one of the best symbols in regular expression land. It's this question basically of, do you want a negative sign? Like, yeah, you can have it if you want it. If you don't want it, then no harm. So that's exactly what that little epsilon transition does. So hopefully you can kind of see these epsilon transitions are going to be connected to this possibly take something or possibly don't take something. Then what happens is I can sit and spin at S1 on whatever digit I'd ever want. So the digits are coming from a bin of numbers from 0 to 9. So I'm actually going to encode that as this big laundry list from 0 up through 9 with square brackets around it. So that's the same as if I were to have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that's going to be a big choose from list, is that I can grab any of those things. So you can essentially view those as all separated by an or. I'm allowed to take a number, but I don't have to take a number, but I can take as many numbers as I want. So that's exactly set up for this little star operator. So that little spin is nicely connected to this star. Then what's going to happen is I'm going to choose to go down one of 2 paths. Basically, I can come across that top row, or I can go down on the green one. And we can actually see things like the negative 13.37 actually funnels into the accepting state on either of those paths. Basically, you could come across on the negative, you could do the 1, the 3, the point, the 3, and the 7. Or you could do the negative, the 1, the 3, the point, the 3, and the 7. However, things like the 0.42 would be negative. I have to take the point here, and then the 4, and then the 2. So in our regular expression world, I'm going to create this little split ski with the classic OR. So the first thing that I want to do is I want to think about how I'm going to incorporate the dot and then the digit. So you might be initially tempted to just write this as dot, and then again, the 0 through 9. And you'd be like, cool, there's my little dot, and move on with your life. Unfortunately, that little dot in regular expressions, once we actually switch to implementation, is going to have an alternative meaning. Just like the star has alternative meanings, that specific keyboard symbol is actually going to be connected to a wildcard. And what I mean by wildcard is that it's going to allow acceptance for any character, and like any character, except for the new line. So I don't really want that there, because this would officially work if I were to put like an exclamation point or a question mark or whatever random symbol I'd want to put in there. So what I need to do is I need to escape this thing. So I'm going to put a slash in front of that to then mean the literal dot, because it's going to require a specific little decimal point. Then I'm going to put a big old vertical bar to separate it with an or, and then I'm going to do basically the exact same thing across the bottom. I'm going to have a digit, so 0 through 9, and then I'm going to have a dot, and then I'm going to close out that or. So I either have going across on the purple route or coming across on the green route. Choose one of those two things. Once I'm done, then I can actually sit and spin on decimals, as many as I would like, so 0 through 9, and I'm going to throw on some stars to say I can do whatever I want to afterwards. So I get this as kind of an initial structure for this. So I'm going to convert this into the typey world. So I'm going to switch into one of these nice little online web app tools. So let me do a swap screen as well as grab a keyboard. So this is RegEx, and I think we are good. Make it resume share, and we have this thing all set up. Move my Zoom stuff out of the way so I can actually see. Okay, so I have this currently set up with a little dot just to kind of remind you that this thing does need to be escaped. So that little dot, if you hover over it, it's going to say it's going to match any character except for these line breaks. So if I were to have like the letter A, it's accepted. So would little a, so would a 0, so would a 1, so would an exclamation point, and even a space. All of those would then be accepted. Whereas if I escaped this, so if I put a backslash, then you can see that things like 9 and 0 and A and capital A are all not accepted, but a nice little dot is. So if you look over on this little cheat sheet, you can kind of see that escaped character. So that backslash dot is then going to give me the literal decimal point. You can see that things like backslash are also going to need to be escaped, as well as the star, because the star has alternative meanings. So basically, if the symbol is used anywhere else in this regular expression land, it needs to be escaped. Cool. All right. So enough of that. Let's go back to actually chatting about some of our decimals. So let me make up my little laundry list of these should pass, and maybe these should fail. So are my examples: -13.37. Jenny's phone number is 867-53099. And what, -0.42? We could also have like 42 point, and things that should fail. Well, just like a negative dot should fail. Things like 1.1.1 should fail. And officially, the number 42, as the meaning of life without the decimal point, is not a decimal number and is in fact going to fail. Okay, so I'm going to switch this to the multi-line setting. So it's going to actually pass each of those. And then I'm going to do the anchoring. So I'm going to put my caret and a $sign. So that's what's in there. So again, I'm going to start it with the anchor and end it with the anchor. And I'm going to begin typing. So it's the option of like, do you want a negative sign? Sure. Do you want some digits? Do you want as many as you'd want? Sure. Then what's going to happen is I'm going to have my split occur. So across the top was starting with the dot and then saying a digit needs to occur. And then coming across the bottom was the digit and then the dot. And then, so you can see right away that the 42 is now passing. And then at the very end, I can sit and spin on as many numbers as I'd ever want. And I should then see everything nicely pass. So the -13.37, the 867.53099, and -0.42 and 42 point. Everything else then you see does in fact fail, which is what it's supposed to. So we're actually in a good position. If I were to delete these little anchors, just to kind of remind you what's happening here, that's going to then still accept all of these things, which is great. But if you actually come down here, you're going to see that it's going to treat this thing as two separate strings. It's going to pass on the 1.1, and then the 0.1 is also going to pass. So I'm going to put on the anchors just to make sure that that thing is all treated as one entity, and then that thing no longer passes. So the four things that should work do in fact work. So this was me typing it up with kind of the writing it out with the actual 0 through 9. If you wanted to, you could actually change these things to any digit via the \D. So that's going to be just general digits. So if I go, I can swap all of those things out and it all works out, hopefully as it should, fingers crossed, and it all does. So you can see that it's slightly fewer keystrokes to actually get the exact same thing. I actually kind of like the initial look of just the 0 through 9 when I first type them out, just because it is very obvious as to what it is. And then I come back and clean it up afterwards, because otherwise it's too many escaped characters and it just hurts my brain. So I'm going to put it back like that just because I want to make a couple more comments about this specific example before we go into a couple of other ones. So if you look at this, we have kind of a little bit of redundancy. We have this initial spinning on initial characters. Then I go into one of two bins. The first bin is having a dot with stuff afterwards. The other one is a dot with for sure things in front of it. If I were to just completely delete this thing from my regular expression, you're going to see that the -0.42 passes. Anything that would just be a decimal with stuff afterwards is still going to pass. So that's okay. I, however, am missing some of these other things. But the other things all are in the scenario that they for sure have stuff in front of them. They have at least one thing because they're all coming across on this path, because they're not coming on this one because there's not a number in front of it. So they're all coming in on this one, which requires at least one number. So what I could technically do is I could change that 0, 9 as having one copy of it to having any number of copies, at least one. And to do that, I'm going to not use a star, but I'm going to use the plus. So that's going to represent this. I'm going to choose at least one digit, and I can choose as many as I would want them to be. So structurally, you can actually organize that in this fashion as well. I think technically on the notes, I flipped the order of these just because that's how I like to think about it in my head. So I would have things that for sure have one number in front of them, followed by a dot. And then if you want numbers afterwards, and if you don't fit in that camp, well, then what had to happen is you had to have a dot, and then you could potentially have numbers afterwards if you would like it like that. And then you can have as many if you want as well. So you can technically shorten that up. Again, go back to the \D's approach if you want to make it a little bit shorter, and then kind of slowly clean things up. So that's actually how I like to think about building these machines. Is I like to design maybe the first little machine, and then from the machine, go back and kind of create an initial regular expression. I like to get something that works. And then once I get something working, I like to then come back and begin thinking of like, oh, I can fix this redundancy, or I don't need this, or these things can actually be morphed together to slowly make a slightly more efficient system that has maybe fewer keystrokes and all of the goodies that we know and love about regular expressions. So we slowly introduced a couple new characters. The big important one here was this bracketed structure of the OR. So we're going to see things like, whoa, you know, a bracket with a 0, 1. That's going to look a lot like if you were to have 0 or 1, but that's just going to be a nicer shorthand way of typing this thing up. So if I have a bigger list, so like all of the numbers from 0 to 9, you can just write this as 0 to 9 in the bracketed structure. And then that's actually going to keep on snowballing as we go forward. So I'll pause it here, and we're actually going to go ahead and jump into another language and then rinse and repeat this a few more times.